Okay, 3/4 minus 1/12. The subtracting isn't any harder. It just means at the end we'll be subtracting. Remember to leave some space here when you write your problem. So brute force method, do I think about anything at the beginning? No, I just write each number on the bottom next to the other one. So the 4 is going to get a times 12. The 12 is going to get a times 4. If I do it to the bottom, I have to do it to the top. So what do I wind up with? 3 times 12 is 36. 4 times 12 is 48. Minus 1 times 4 is 4. Oops, over here. And 12 times 4 is 48. 36 of something minus 4 of something is 32 of something. As often happens with this brute force method, I have to reduce. What should I start out by reducing with? We can certainly pick 2. They're both even numbers. Should we just do 2? 4? 4 will also work.
Well, 8 work.
8 will also work, but I've started writing 4. So you can do 8 on your paper. So 32 divided by 4 gives me 8. And 48 divided by 4 gives me 12. I'm not quite there yet. So I'll divide by 4 again. And I get 2/3. Everyone happy with that? Okay, list of multiple methods. I still have 3/4 minus 1/12. I still left my space here to put in something. Let's start writing my list of multiples. So multiples of 4, 4, 8, 12. Oh, I can see what's going to happen, right? In the list of multiples of 12, I already have one that's in common. So yay, there we go. That was pretty quick. What is it multiplied by in my list of 4? It's a times 1, times 2, times 3. So it's going to be a times 3, just in case I didn't know 4 times 3 was 12. Nine twelfths minus 1/12 is 8/12. And just like before, when we had 8/12, we have to reduce it. But there's not as much reducing as the brute force method had. Questions about either of those two? You either got it or you're stunned or it's too late and you're falling asleep. Okay, prime factorization method. So I write the same thing to start with. I'm going to make a factor tree of 4 and a factor tree of 12. I'm going to cheat. Anything that's on the same factor, anything that's the same on both factor trees, I just wrote once. It doesn't really matter that I broke it down from 6 into 2 times 3. So on this one, I could change my 4 into a 2 times 2. And when I have a 4, oops, why is that 12 green? 12, be green. So I could make this a 4 and break the 4 down, but I have a 4 here. It doesn't really matter if I break them down into 2 times 2. I'll just leave them as the same. So now I do that step of making my list. So there's a 4 on both trees. If I did 2 times 2, that's fine. That's just another 4, right? And then this list only had a 3. So I'll put it there. So 12 is my common denominator. And the 4 tree will need a 3. So exactly the same math as before, but thinking about it a very different way. I got my 9/12 minus 1/12, which is 8/12, which is 2/3. That's sort of off to the side now. And I need my little divided by 4s. That's a lot on one page. Again, you don't need to do this 3 times. I'm only doing this 3 times because I want you. You can do this your favorite way, not do it the other 2 ways. Any questions about this one? Okay.